All right, we're going to look at our third example here. This is what most of our skill is going to be like, which is including some algebra review. We're going to ignore this SC there. I typed that by accident. And there is an typo in my original. My XY needs to equal 3A. So make sure you adjust that. And this question asks, mind you, we're asked to find two things. We're asked to find the value of A and to find the value of XY. So for our answer to be completely correct, we need to make sure we're labeling two answers at the end, okay? So I like to maybe put a little reminder at my bottom that I want to find A equals and XY equals, because I can tend to forget. I find A and I'm like, done, and I move on. So sometimes scrolling to the bottom and adding that helps remind me to go back, okay? All right, and in this case, we're not given a figure, and in geometry, we almost always want to have some sort of visual figure to reference. So if we're not given one, we want to draw one. In this case, we're told that y is between x and z. So if I'm going to draw a figure, if y is between x and z, which of these, x, y, or z, should my middle dot be? Why? Because that's the only place to be between two other points. And then x and z are my endpoints. And which order you label the endpoints is not especially important, as long as we're able to see that. And that's going to help us set up our problem. I like this, not required, but I do like to put any of my information on the diagram that I can. So I'm told xy is 3a. I'm going to go ahead and label that. And let's see here, YZ is 14. And XZ is 5A minus 4. All right, then, describing the relationship in words when I have three collinear points that I'm trying to find some kind of distance in. This is our betweenness theorem. Or I like using whole equals sum of parts. This is a little more generic. In the IXL, if you work a problem and it's showing you got it wrong or you ask for an example, it's going to say the additive segment addition theorem. That's another application of this. Any of those are fine. Okay, then write the equation for the relationship. So one of the reasons I like whole equals sum of parts is that reminds me I'm going to start with my whole xz equals the sum of my parts, xy plus yz. And this is what we need to do on a test, is go through each of these steps. So it's another reason why we're doing this example. And by the way, on the test, I will do at least one problem with a chart like this, so you're reminded of all of the steps as a reference, okay? All right, then identify and label your known variables. In this case, the problem itself actually gives me all three of these labels. I'm fine with just drawing an arrow. That's okay, they're already listed. And then substitute our known values for the variables in the equation. So this is where I'm going to look at my equation. I have xz here. I know that xz equals 5a minus 4, so I'm going to substitute that. And then I have xy, which I know is 3a, so I'm going to substitute that, plus yz, which I know is 14. I'm going to substitute that. I'm adding the coloring so to help you see. One of the things I get when teaching Mrs. Weaver, where did that come from? Where did you get that? So that's something additional. It's a metacognitive technique that I add to help you trace where things are coming from. You don't have to be doing your work in 8 different colors, okay? So just know that, take that stress off if it's something you're feeling. This should actually be down here, but that's okay, we need some space. So I've substituted. Now I can solve for my unknown, and this is where I'm going to use my algebra, order of operations. First of all, our first step if we have variables on both sides is if we don't have any terms to combine, is we want to get down to just one variable term. Which variable term do you guys want to get rid of? The 3a. All right. So to cancel out a 3a, I'm going to subtract a 3a from each side, leaving me 2a minus 4 equals 14. Now I just have one variable term. I want to isolate that variable term. What is keeping that term from being by itself? What's the name? The negative 4. So how can I cancel out the 4? There we go. Add 4 to both sides. So now 2a. This is my additive inverse property. Negative 4 plus positive 4 cancels out to 0. 14 plus 4 is 18. What is my last step to now isolate the variable itself? Divide both sides by 2. There we go. This is my multiplicative inverse property. 2 divided by 2 is 1a. 18 divided by 2 is 9. A couple things I want to check. Did I have any units? There were no units given, so I'm fine there. What else? Am I done?
No.
No, why not? We still need to find xy. So I'm going to go ahead and copy this down here, my a equals 9. How do I find xy? Well, what was xy given as? So xy at the top was given as 3a. I substitute the 9 in for a. Okay, that's coming here. And therefore xy equals 27. And that's it. All right, so if you need an extra review of the algebra approach, that is it. All right, we're on objective 2, which is working with congruent segments. We're going to identify congruent segments, including their symbols. How do we know something is congruent? We're going to apply congruency, and we're going to create congruent segments. So we're going to start with what is a congruent segment. We explored this with our lab. Congruent segments have the same, congruent anything is the same measure and the same shape. In this case, congruent segments, the segment is the shaped part. Like you have a triangle, you have a square, you have a segment, you have a point. Those are shapes, quote unquote. All right, even though we tend to think of shapes being a triangle and above. A triangle is a 3-sided shape, square is a 4-sided shape. A segment is kind of like a 1-sided shape, and a point is like a 0-sided shape. Okay? So we have some important symbolism here. This symbol, and you can ignore the dot on top. I could not find a version that didn't have the dot on top. But this equal sign with a tilde on top is called a congruency symbol. We just read it congruent to.
It's a Spanish equal sign.
Okay, so it means congruent to. So if I said this is red segment, because of my segment symbol, AB is congruent to, let's color code this. Segment AB is congruent to segment CD. And we're going to practice in class reading these the geometric language in a separate assignment where we'll get to just practice it a lot all together once we have all the basic geometry vocabulary. On diagrams, we indicate congruency with this little tick mark on the figures. So this tick and this tick mean that this segment here is congruent to this segment.
Oh, so that's what the line means.
That's what the line means. I could now draw another segment, EF, and another segment here, GH. And let's say I want to indicate that these two are congruent, then I would use 2 tick marks. So I know that my AB and CD make a pair, and my EF and GH make a pair. In fact, I could add an additional segment, IJ, and add 1 tick mark and that means that it is now congruent with these other two. Okay, I've seen up to 3 tick marks. It's rare that we use 4, but because we do a lot with triangles, we'll have just a whole month on triangles. We'll use 1, 2, and 3 tick marks pretty frequently. Yes, ma'am. All right, so that's our basic concepts. Let's look at some application. Our segments HI, I like to mark these down, HI, and segment GI, congruent. So I want to double check, what does congruent mean? Same measure and shape. Are they the same shape? Yes, because they are both segments. So that's just automatically built in that they're the same shape. Are they the same measure? No, so they are not congruent. We could say not congruent, or we can write HI is not congruent to GI, segment GI. For our second example, could we conclude that segment FG and segment EF are congruent? Yes, why? Yes, they have the tick, which tells us they're the same length. Even though we weren't given the actual measure in numbers, we know they're congruent because of the tick marks. So we can say that yes, FG and segment EF are congruent, or more to write it more shortly, we could say segment FG is congruent to segment EF. So let's take a look at the next page. Now we have a third example. Here we're going to apply congruency. We're told that CD equals 4 centimeters. I like labeling things. If I know something, I always like to write it on my diagram if possible. And I'm told that GF, scroll down just a touch, has a measure of 2 centimeters. And I'm asked to find the measure of HI, HG, and EF. So you'll see I have a separate set of equal signs here. That's because in the middle, I want us to write which of our known segments is each of these segments congruent to first. So HI, I'm going to mark that in green. Which of my known segments is HI congruent to? CD. So I'm going to write CD. How about HG? Which segment is HG congruent to? What was that? Of my known, the one yellow or blue. The CD or the FG? CD. Very good. And which segment is EF congruent to? FG. Okay. So the measures of these segments are going to be equal, going to be the same measure. So if HI is congruent to CD, then HI has a measure of 4 centimeters because that was CD's measure. Same thing for HG, which is also congruent to CD. EF was congruent to FG, or GF, which is 2 centimeters. Make sure we have our units and that we've answered all parts, and we're done. That's it. This is just practice reading the congruency symbols, that CD was congruent to IH and HG because they have 2 tick marks, while EF was congruent to FG because they both have 1 tick mark. Regardless of how it looks, we go off of what's marked. Okay? All right, great. Last part is constructing line segments. Now we did this with patty paper with tracing, but there is a way to do this with a tool called a compass. This is more of a lab portion, so I'm going to ask you all to take out a sheet of notebook paper, and then we're going to come back to the notes in a second. All right, so we're going to have 3 steps. Our first is to draw a new line with the point where I want to create my copy, or in geometry, a copy is called image. I'm going to measure the initial distance with my compass, and then I am going to use that to create a little tick mark on my new line. So we'll see that here. I have CD, and I want to copy it onto AB, so I'm going to draw a line. I'm going to put a point A on this line. And then my compass is trying to measure a length, basically using a circle. So what I'm going to do is line a circle up. Hopefully, I want a circle where the center is on C and the radius is on D. So I'm going to keep adjusting this. A little bit easier with your compass than what I'm doing, but the basic idea is here. All right, so my center of my circle is on C, and my circle intersects D. This circle is what our compass is tracking, and then we can move, move that circle so the center is on A instead. And where the circle intersects the line is going to be my other endpoint, B. That's our process. Objective 3, finding distance on a number line. This is really easy, but it's important that we follow our steps, okay? Because this is preparation for more challenging work later. I've explained this to classes in the past. I've said when you first go, let's say you get a personal trainer at the gym and you want to lift free weights. They're going to start you on some low, if it's your first time doing free weights, they're going to start you on low weights, and then they're going to focus on, are you doing your form properly? Because doing your form properly is going to mean you're going to reduce injuries, and you're going to be able to carry heavier weights in the future. So we start with the light weights, and we focus on form. This is a lightweight skill. We're going to focus on form. So when we get to the heavier weight stuff, you can do that without injury or crying and weeping and gnashing of teeth. And I've literally had parents email, my kid is crying because they don't know how to do their assignment. Just relax. Come see me. If you don't understand, if you're stuck, you're frustrated, just come see me. Get help. I want to help. It's okay. But this is a following form time, okay? So when we're finding distance on a number line, here's what I've seen students do, even when I told them not to. There was some marks here, and they just go 1, 2, 3, 4. It's 4. I'm like, no. So I don't even give questions that you can do that on anymore because we're trying to take a shortcut. We're using bad form. We want to focus on the form here for problem solving. So when we're finding distance between 2 points, distance is an absolute value. It's always going to be a positive number. If you get a negative number, you've missed the absolute value is probably what it is. And then to find it accurately, we almost always want to do our second number minus our first number. Okay, so if we have 2 points, we are finding the coordinate of Q minus the coordinate of P, and then we're going to take the absolute value of that number. Okay, so and this is distance on a number line. If you want to underline / highlight, here's our relationship in words. All right, and then for our initial equation, you could use either of these versions. Okay, this is our equation. And I find the models often helpful for me to spot what am I looking for. All right, this example is from page 17 in your textbook. Our first question says, use the number line to find BE. Okay, so I'm finding a distance on a number line. That's my relationship in words. And one of the preps I'm going to give you in advance of the test is going to be giving you problems and just asking you to choose which word relationship does this problem go to. Separate from all the calculating, just so we can get practice with identifying our relationships. All right, so that's something that you're going to see ahead. Then write an equation for the relationship. I have 2 options. Well, no, what I want for our initial equation is just variables, no numbers. So that's going to be my distance BE equals Remember my second coordinate, E, minus my first coordinate, B. E minus B. There we go. Now, which of these variables do I know? I know that B equals -6, and I know that E equals 2. Again, really easy, but we're focusing on that form. And then I'm going to substitute my known values into the equation. I don't know BE, that's what I'm trying to find, so that comes down. E, I know is 2. Oh, sorry, absolute value of. I forgot the absolute value. It's important. So absolute value of E is 2 minus B is -6. And I close my absolute value symbol. When first filling in my known values, I'm not trying to simplify any. Don't try to fill in and simplify at the same time right now. Later, I'll say, okay, we've got some good form. Now we can start taking some shortcuts. Right now, I just want to focus on that form. So I have a separate spot for each. In the solving, that was a great question. In the solving, now we're going to simplify. So BE equals the absolute value of 2 minus -6 is 2 plus 6, which makes 8. And the absolute value of 8 is what?
8.
8. Absolute value is always positive or 0. Now, I didn't have any units here, so that is my answer, and I've labeled it. BE equals 8. And I could verify that if I had the little, I moved things around so that you can't use the tick mark approach. So I'm in there photoshopping things. All right, then our next question is determine whether segment CA and segment ED are congruent. For two segments to be congruent, what needs to be true of them? Same size and shape. Same size, that's our measure, and same shape. They are both segments, so same shape is good. We need to find their size. That's going to be distance on our number line. Since I didn't include the steps here, I'm okay if we want to do a little bit of a shortcut here. We've got CA equals and ED equals. So CA is going to be the absolute value of A minus C. And ED will be the absolute value of D minus E. A is -7 minus C is -5. Notice I'm not trying to simplify. D is -2 minus E is 2. -7 minus -5 is -7 plus 5, which is the absolute value of -2. -2 minus -2 is -4. Their absolute values are 2 and 4. Do they have the same measure? No. So CA is not congruent to segment ED. All right, and that is the end of our lesson for today.